Hello, can you hear me? Can somebody confirm that I'm audible? Confirm that I'm audible. Yes, so got the confirmation that I'm audible, so I'm gonna uh, start the discussion for today's session. So, good morning, afternoon, or evening, wherever you are. My name is Amir Abbas, and I'm excited to be here today to talk to you about supervised machine learning. In this presentation, we'll cover the basic concepts, processes, algorithms, challenges, and future of supervised machine learning. But before we move forward, I would request that if you have not yet subscribed to this channel, please subscribe to this channel so that you can get the notifications for all the videos being uploaded to this channel. And do not forget to press the bell icon. So now let's get started. In this presentation, we'll talk in detail about supervised machine learning. That includes its definition, examples, related concepts, a brief overview of the process of making a supervised machine learning model, and feature of supervised machine learning. To begin, let's define supervised machine learning. Supervised machine learning is a type of artificial intelligence that uses labeled data to train models to make predictions or classifications. Labeled data is data that has both input features and labels and is used to train models to make predictions. Predictions are output values generated by models based on input features, while classifications involve assigning input values to categories or labeled based on models. Here are some of examples of supervised machine learning applications. Supervised machine learning algorithms can be trained to classify images of skin lesions as either cancers or non-cancerous. The model is trained using labeled data of images that have been verified by a dermatologist and can then be used to assist in diagnosing the skin cancer. Supervised machine learning algorithms can be trained to analyze brain imaging data to identify patterns that are indicative of Alzheimer's disease. This can help diagnose the disease at an earlier stage, allowing for more effective treatment and management. These algorithms can be trained to analyze large amounts of patient data to identify patterns and disease and predict which treatments will be most effective for individual patients. This can help healthcare providers personalize treatment plans for each patient, leading to better outcomes and reduced healthcare costs. These algorithms can also be trained to predict patient outcomes based on a range of factors such as age, medical history, laboratory test results. This can help healthcare providers identify high risk patients who may require close monitoring or aggressive treatment. Now that we know that what supervised machine learning is, let's discuss some of the basic concepts. Labels are the output values that model is trying to predict or classify. Features are the input values that the model uses to make predictions or classifications. There are two main types of supervised machine learning: regression and classification. Regression involves predicting continuous values, while classification involves predicting discrete values. The process of supervised machine learning involves several steps. The first step is data preparation, which involves cleaning, pre-processing, and splitting the data into training and testing. The second step is model selection. The sec, which in the model selection involves choosing the appropriate algorithm and architecture for problem at hand. The third step is model training, which involves feeding the labeled data into model and adjusting its parameter to minimize the error. The fourth step is model evaluation, which involves testing the trained model on a testing data and evaluating its performance metrics. The final step is model deployment, which involves using the training model to make predictions for classification on new data. There are several supervised machine learning algorithms that are commonly used. Each with its own strengths and weaknesses. Linear regression is used for predicting continuous outcome. Logistic regression is used for binary classification problems. Decision tree are used for both of regression and classification problems. Support vector machines are used for binary and multi-class classification problems. There are several examples of the use of these algorithms. For example, predicting blood glucose levels. Linear regression can be used to predict blood glucose levels in diabetic patients based on factors such as age, weight, insulin dosage. This can help healthcare providers optimize treatment plans for diabetic patients and reduce the risk of complications. Predicting hospital readmission is another example. Logistic regression can be used to predict the likelihood of a patient being readmitted to the hospital within 30 days of discharge. This can help healthcare providers identify high risk patients and develop targeted interventions to reduce readmissions. Decision tree can be used to diagnose respiratory diseases based on symptoms such as coughing, wheezing, and shortness of breath. This model can help healthcare providers to make accurate diagnosis and develop appropriate treatment plans for patients. Support vector machine can be used to classify tumors as either cancerous or non-cancerous based on features such as shape, size, shape, and texture. This can help healthcare providers make accurate diagnosis and develop effective treatment plans for patients and for cancer patients. Neural networks are another supervised machine algorithm that are particularly well suited for processing unstructured data. A neural network is composed of layers of interconnected nodes or artificial neurons which process and transmit information. There are several types of neural networks, such as feed-forward neural networks, convolutional neural networks, and recurrent neural networks. Some advantages of neural networks include their ability to model complex relationships and their ability to learn from raw data. However, their limitations include their computational complexity and their tendency to overfit. Neural networks can be used to predict patient outcomes based on a range of factors such as age, medical history, and laboratory test results. The model is trained on labeled data of patient outcomes and then can be used to predict the likelihood of a patient experiencing complications or requiring readmission. This can help healthcare providers identify high risk patients and develop personalized treatment plans to improve outcomes and reduce healthcare costs. Neural networks are particularly well suited for this task because they can model complex relationships between multiple variables, allowing for more accurate predictions. Neural networks can be used to predict seizures in patients with epilepsy. The model is trained on EEG data and can then be used to identify patterns that are indicative of an oncoming seizure. This can help healthcare providers anticipate seizures and take preventive measures such as adjusting medication dosage, or initiating electrical stimulation to reduce the frequency and severity of seizures. Neural networks can be used to identify cancerous lesions from medical images such as CT scans or MRIs. The model is trained on labeled data of images that have been verified by a radiologist and can then be used to assist in diagnosing cancer. This can help healthcare providers make more accurate diagnoses and develop appropriate treatment plans for cancer patients. Neural networks are particularly well suited for this task because they can help to identify complex patterns in medical images that may not be visible to human eye. Ensemble method are another supervised machine learning technique that involves combining multiple models to improve performance. Ensemble methods can be used with any supervised machine algorithms such as decision tree or neural networks. There are two main types of ensemble methods: bagging and boosting. Bagging involves training multiple models on different subsets of training data and combining their predictions, while boosting involves iteratively training models on misclassified data to improve performance. Some of Some advantages of ensemble methods include their ability to reduce variance and their ability to handle noisy data. However, their limitations include their increased complexity and their sensitivity to bias. Boosting is another ensemble method that combines multiple models to improve accuracy. It can be used to diagnose respiratory diseases based on symptoms such as coughing, wheezing, and shortness of breath. The model is trained on labeled data of patient symptoms and can then be used to make accurate diagnosis and develop appropriate treatment plans. Boosting is particularly useful when there are many weak classifiers that need to be combined to achieve high accuracy. Voting is an ensemble method that combines the prediction of multiple models to make final decision. It can be used to identify patterns in brain imaging data that are indicative of Alzheimer's disease. The model is trained on labeled data of brain imaging scans and can then be used to assist in diagnosing the disease at an earlier stage. Voting is particularly useful when there are multiple models with different strengths and weaknesses that can be combined to make a more accurate diagnosis. Hyperparameter tuning is the process of finding the optimal set of hyperparameters for a given algorithm and problem. Hyperparameters are the configuration parameters that are set before the model is trained, such as learning rate, regularization, strength, and the number of hidden layers. Hyperparameter tuning is important because it can greatly affect the performance of the model. There are several techniques for hyperparameter tuning, such as grid search, random search, and Bayesian optimization. Hyperparameter tuning can be used to identify the most relevant markers for predicting cancer outcomes. The model is trained on labeled data of patient outcomes and can then be used to identify the most important feature for predicting the cancer outcomes. Hyperparameters such as learning rate, regularization, and number of hidden layers can be optimized to improve model performance. Hyperparameter tuning can be used to improve the accuracy of models used to predict disease progression in patients with chronic diseases such as diabetes or heart disease. The model is trained on labeled data of patient outcomes and can then be used to identify the most important features for predicting disease progression. Hyperparameters such as learning rate, batch size, and optimizer can be optimized to improve the model performance. Hyperparameter tuning can be used to identify the most relevant genetic factor for predicting the likelihood of developing certain diseases. The model is trained on labeled data of patient outcomes and can then be used to identify the most important genetic factor for disease. Hyperparameters such as regularization, number of hidden layers, and activation functions can be optimized to improve the model performance. This can help healthcare providers develop personalized treatment plans on a patient's genetic risk factor. While supervised machine learning has many benefits, there are also several challenges that need to be addressed. Overfitting and underfitting can occur when the model is either too complex or too simple. The bias variance trade-off is the balance between the model's ability to fit the data and its ability to generalize to new data. Feature selection is the process of selecting the most relevant features of the model. Data imbalance occurs when one class is much more prevalent than the other. Model interoperability refers to the ability to understand how model is making its predictions or classifications. One of the challenges in supervised machine learning is overfitting. Overfitting occurs when the model is too complex and memorizes the training data, while underfitting occurs when the model is too simple and cannot capture the patterns in the data. There are several techniques for addressing overfitting and underfitting, such as regularization, early stopping, and cross validation. Another challenge in supervised machine learning is the bias and variance trade-off. Bias refers to the error introduced by the uh, assumption and made by the model, while variance refers to the error introduced by the model's sensitivity to fluctuation in the data. There are several techniques for addressing the bias and variance trade-off, such as adding more data, increasing model complexity, and changing the algorithm. Feature selection is the process of selecting the most relevant features for the model. This is important because including irrelevant or redundant features can lead to overfitting or decreased performance. There are several techniques for feature selection, such as methods, filter methods, wrapper methods, and embedded methods. Data imbalance occurs when one class is much more prevalent than the other. This can lead to biased models that perform poorly on the minority class. There are several techniques for addressing data imbalance, such as resampling, cost sensitive learning, and ensemble methods. Model interoperability refers to the ability to understand how model is making its predictions or classifications. This is important for understanding the model's behavior, detecting biases, and building trust with with the stakeholders. There are several techniques for model interoperability, such as feature importance and partial dependence plots. As supervised machine learning continues to advance, there are many exciting developments on the horizon. These include advancements in deep learning, natural language processing, and computer vision. However, there are also important ethical and social implications that need to be considered, such as bias, privacy, and accountability. There are also many challenges and opportunities for future research and development, such as explainable AI, supervised learning, and reinforcement learning. Please give us thanks for watching this video, and please give us your feedback in the comments and feed. If you have not yet subscribed to this channel, please subscribe to this channel so that you can get the notification for all the videos being uploaded to this channel. Please, and do not forget to press the bell icon. See you all in the next video.